Oakley dokley. So the differentiability of not just a piecewise function, but any function, is first that it needs to be continuous at the point where you're checking for differentiability, which means you have to look at the limit from the left and limit from the right and hope that they're the same as the functional value. Then you find f prime of x by doing, in this case, the pieces of the piecewise function from both directions and determine if the derivative itself is continuous. So that's what makes something differentiable, is if its derivative is continuous. So the absolute value function is not differentiable, in particular at this point right here, because the derivative over here is -1, the derivative over here is +1, and so the derivatives don't match up. You can't draw a tangent line here. It's not smooth. Okay, so determine whether this particular function is differentiable everywhere. Okay, it's definitely differentiable on its respective domains, right? The parabola and the line, those are just polynomials. They're definitely differentiable, but there's a concern where we jump from one piece to the other piece, namely at 1. So first, let's make sure that f is continuous. That should be our first thing to check. So if we take the limit as x approaches 1 from the left of f of x, that means we are taking the limit as x approaches 1 from the left on the left branch, which is the x squared minus 3. And if we stick 1 in here, 1 squared is 1, 1 minus 3 is -2, so this is equal to -2. On the other hand, if the limit as x approaches 1 from the right, we will be coming in on the other branch, which is the 2x minus 4 branch. And if I plug in 1, I get 2 times 1 is 2, 2 minus 4 is -2. So since the left-hand limit and the right-hand limit are the same, and it's equal to the functional value because of the less than or equal to, that means f is continuous at x equals 1. If it weren't continuous, you're done. Differentiability cannot happen. Second part of the process then, let's check to see if f is differentiable at that point. So to check f is differentiable, f prime of x, the derivative of x, is going to be the derivative of x squared minus 3, which is 2x, on the interval when x is less than 1, not less than or equal to, but less than 1. And then it's going to be the derivative of 2x minus 4, which is 2, if x is bigger than 1. So we hope that this is going to be set up in such a way that when x equals 1, we have the same number from both directions. So let's see. We're going to do a couple limits here. Let's do the limit as x approaches 1 from the left of the f prime, which is the limit as x approaches 1 from the left of 2x, and of course 2 times 1 is 2. If we do the limit as x approaches 1 from the right, we have the limit as x approaches 1 plus of just the number 2, which is also 2. So from the left and from the right, the derivative is both equal to 2, and so that means now we can complete the derivative. When x equals 1, it'll actually exactly be equal to 2, and so therefore f is differentiable everywhere. Again, the only concern was the concern that happened at 1.